Hi, everybody. My name is Tavleen. I am a production engineer at Meta, and I am part of this organization called Infrastructure Security Engineering. Today, I will be talking about how we maintain network security in a company like Meta, which with networks that span the entire continents, actually the entire world. All right, let's quickly walk through the agenda. We'll talk about different aspects of infrastructure security, types of filtering, introduction to firewalls and ACLs, and what issues can we face with manual maintenance. I'll then talk about a tool called Capirca that we use in order to maintain network security filtering at Meta. A little bit about safety services that we've built around Capirca, which itself is a security safety service. And then these are all the listed safety services that we'll be talking about, and finally the conclusion. All right. So when it comes to infrastructure, it is a very security in infrastructure is a very layered and non-negotiable component. When I say layered, it means that we have multiple layers of TCP/IP stack, and at every layer we make sure that we are able to secure our infrastructure in a way that one, we authenticate it, and other, we filter out stuff. So what authentication means is you are who you are claiming to be. Filtering means once we've established who you are, who you're claiming to be, we decide whether or not we want to allow you inside of the infrastructure that we're filtering through. So at the topmost layer is physical security. We maintain this by using card readers and identity cards at the data centers. We have network security, which involves securing our network infrastructure. This is done by the means of firewalls, and this is what we will be talking about mostly today. Next is host security, which involves securing end hosts, including mobile devices and laptops. Application security, which involves securing the applications which run inside of our network or which are hosted inside of our infrastructure. Okay, finally, we have data security, which involves securing data at rest and data in transit. This we do. We have multiple teams that do this using multiple encryption techniques. All right, next is types of filtering. We have these types of filtering, but today we'll be focusing on network-based filtering. So network filtering involves taking necessary measures to protect the network infrastructure from unauthorized access and misuse. In a company like ours, every month we face about 10 Gbps of denial of service attacks. If you consider, this is huge. This can be thought of as internet traffic for a lot of small countries, and this is how much traffic we receive every month just in order for our systems to be compromised. So we need to take proper measures in order to block these denial of service attacks. This includes protecting our sensitive data. We host a lot of sensitive data inside of our company, and we need to make sure our infrastructure security does not compromise with the sensitive data. We need to protect companies' network from external attacks. Also need to keep the network performance improved at all times so that users can connect to our family of apps or other information that we've hosted inside that we want users from internet to be able to access. This includes engineers trying to connect to their office resources. And if all of this works fine, we're able to save cost, which again spans millions. So, firewalls are the most basic form of network security. These are devices that monitor incoming and outgoing traffic, and we do some sort of stateful packet inspection in order to maintain a record of the network connections. You can think of firewalls as both physical and hardware. In network infrastructure currently, we mostly use hardware firewalls in order to do deep packet inspection. Inside of firewalls, we have access rules, which are defined set of security rules. The network filters these are basically network filters that may match traffic based on the information that exists on the packet. So whenever a packet comes inside, we check what are the source and destination IPs and port information on that packet, and depending upon that, we match it to an access control list. Okay, this is a very basic representation of where a firewall is placed in the network. So we have internet, which is the outside world, and then we have our trusted network, which is trusted and untrusted network inside of the company. Firewalls are generally placed at the edge in order to protect what comes inside from the internet, at the same time to control what can be accessed out into the world by the internal company resources. Now, what are the scale of these ACLs that we're talking about? Currently at Meta, we manage about 30,000 access rules, which contain about 550,000 addresses. We end up generating about 1 million access elements across all our DCs and POPs. So the scale is huge, and managing them manually comes with its own issues. We have multiple ACL syntaxes across different vendor devices. The learning curve for all of them is huge. We are prone to manual errors if we want to do this, and it slows down the users that are trying to onboard to network security. Upgrading platform is a complicated process in this case and needs everything to be built from scratch. So in order to solve all of these issues, we came with this framework called Capirca. It is a framework that we use to manage firewall ACLs in our infrastructure. It is an open-sourced security policy compiler by Google. And at Meta, we've transformed this into a self-service tool where users can easily write their policies and in some cases also self-approve their changes. Capirca objects are entities that exist as separate components and can be reused in multiple configs. We have multiple of these objects. First is a network. It is a set of IPs that you want to open or deny access from. We can have a single prefix or a list of prefixes that you can open that can be applied as a source and destination. Similarly, we have services, which is a set of port and a protocol that you want to open or deny access from. Similar to network, you can have a single or multiple services. This is a very basic example of what a network and a service looks like. As mentioned, you can have a list of prefixes, list of ports, or you can have a single prefix and port. This gets applied to an access to a term, which is an access control element. This is like a single rule that decides if any traffic matches this particular term, what should we do with it? Because it has an action parameter attached to it, you decide whether or not a traffic is allowed or denied depending upon that action parameter. So this is what a Capirca term looks like. And once rendered, it gets converted into these syntaxes depending upon which vendor we're using. So on the right-hand side, we have Juniper, and on the left-hand side, we have Arista. This is what it gets transformed to. A project is a collection of terms which is evaluated in the order that we've listed. So terms get evaluated in a top-down approach in a project as we've listed it here. Finally, a culmination of everything becomes a security policy, which it at the end convert to a vendor-specific format and push to a network device. This is what a policy looks like. For simplicity purposes, we've just added one vendor, but we can have multiple vendors here listed, and each of these get converted into its own security policies, and then we apply it to the device in order to decide what sort of traffic needs to be allowed. This is the Capirca config generation workflow. This is how once a user adds their rule into a config file, we then convert it into a vendor-specific format using Python classes. Okay, let's talk about multiple services that we've built around Capirca. This is in order to, so on an average, the network security team at Meta receives about 20 to 25 requests just to decide whether or not a particular access needs to be allowed. And all of these requests are supposed to be reviewed manually and then allowed, because here we're talking about our edge network. And if everything on our edge network gets compromised, Like I said, our users will not be able to connect to our family of apps, and we do not want this. Hence, we've built certain services around Capirca so that a lot of these decision making is one automated and other have a second pair of eyes for us to be make sure that our network is up and running at all times. In order to simplify this, we've converted Capirca into a graph structure. What this means is that the every object that I just spoke about is a relational ent. That way, every object is connected to another in which it is used. So this is what a simplified graph structure looks like. We have a policy at the topmost, a project, term, and then terms have different objects associated with it. And finally, we have addresses and port ranges. This is again a simplified flow diagram, but in actuality, each of these edges also have an edge to the entity on top of it. So the first service that we've built around Capirca security policy is a risk assessment engine. What a risk assessment engine does is once a user, when I say user, I mean a team a team at Meta submits its security policy for review, we analyze that what all changes are requested by them. When I say analyze, we break down that one change into smaller subsections and then break it down into what exact objects are being changed. So if a network is being changed, if a service is being changed, a project is being changed, or a policy is being changed. Each of these individual objects then run through a checker, and that checker assigns a security risk to that particular smaller change. We then combine all of these changes and give one risk to that entire change and decide whether or not this is critical. If a change is critical enough, we then let only the security team decide whether or not this goes through. If it is not that critical a change, users can then self-approve their changes. This is an example. On the right-hand side, a term's getting added. We're adding an SSH access to it. Secure shell for us is a high-risk change, so we automatically tag this as a high-risk change. Similarly, on the left-hand side, we're adding a network which has a large enough prefix, so this also gets assigned a high risk. We have some flow guardrails. There are some services that are very important, or actually I'd say some critical flows that always need to be open. These can involve some important changes like finance related flows so that finance team can access their databases, etc. At any time, if any of these flows get blocked, that can result in a revenue loss. So we make sure that these changes are always up and running. These flows are always up and running, and if any change that is made blocks these critical flows, it is flagged and it is not then rendered onto the box. We've also built a memory profiling that makes sure that any new ACL changes that we make do not result in memory issues on the new device. All right. Finally, we have an auditing pipeline. It is an automated job that runs on all our configs. It loads our graph structure and runs some predefined auditing scripts. If any of our audits fail, we print an internal perusal reports. These audit reports are used both by internal and external auditors that regularly audit our workflows. Okay, what are the wins that we get from this particular system? We're able to deep inspect all our security changes. With this, we reduce time authoring and reviewing ACL changes. Our resolution time is faster, and we have a safer development environment. As a conclusion, we've successfully managed millions of access rules across diverse network infras within Capirca. We've implemented a risk assessment engine to monitor and control our network access. Again, we've done all of this very efficiently, and the solution is scalable enough for us to have seamless upgrades of network devices. In future, we're working on making the process for onboarding a new platform faster. Currently, it's a slower process. We have an in-house UI solution, but we're working on one, supporting this to visualize Capirca configs in a better way. Other, also outsourcing this for more users to be able to use it. Thirdly, we lack simulation techniques. A lot of times our security changes are tested after hours on production networks. We're trying to build an in-house simulation technique to be able to test these changes. Thank you. That was my presentation. I hope you like it. If you have any questions, please let me know. The question is that even with all these checks, we push something and it ends up breaking something. Do we have like circuit breakers implemented either using Capirca or through other systems? The short answer is no. The reason behind that is because a lot of this infrastructure is distributed across continent. And so we do not have direct access to be able to run that circuit breaker because the physical locations are distant. So yes, we've seen outages. So in order to avoid these outages, there's a very planned approach as to how we deploy our changes. It is a phased approach wherein the changes are deployed one after the other. And we have this internal system called canarying the changes, wherein we let them bake in for a few days and then push them. So 99% of times we've been able to avoid any issues. We do have issues happening, but the recovery time is pretty faster with that. Thank you. Any other questions? Hi, thank you so much.